Hello, guys. Welcome to another episode of CUDA Education. Today, we want to do our first entry into the concept of volumetric scattering. Now, I previously did a quick video on the topic, but what I plan to do with this series is kind of bit by bit get more in depth into the conversation of volumetric scattering. Now, this episode, I just want to keep it very light and surface level and not get too complex because, I want you guys to just have an easy intro to this stuff and, you know, we get going. So volumetric scattering basically is the mechanism by which the computer graphics application, uh, simulates fog in a scene. Okay, so when we look at running this particular application, we will see that we have we have a scene, and you could see that there is a simulation of fog. Okay, now what I want you guys to pay attention to for our purposes today and for this episode specifically is just kind of look at the quality of the fog, right? So especially this right here and also this right here with the spotlights, right? Um, um, the fog also, you could see it around the point lights, but it's more pronounced over the spotlights, but just because of the high intensity of the beam that goes through the fog here and here. Okay, so volumetric scattering is basically simulating fog. That's the whole purpose of it. It's how do you basically how do you create fog? Now the language of volumetric scattering, there's one particular word that I want to introduce and I want you guys to get used to. The word is called voxel. Okay, it's Voxel. Okay, voxel. Voxel. A voxel is sort of the I guess you would call it the primitive or the unit, or sort of the most granular thing that you would use when you're talking about processing fog. Okay, so what a voxel is a three-dimensional version of a pixel. Okay, so you guys know what pixels are, right? You could think of a pixel as maybe, you know, I personally think of it as a two-dimensional dot um, on basically a dot on a two-dimensional surface, right? So for example, you have printer paper, right? If you take out a sheet of printer paper and you look really closely at the printer paper, right? Like you really put it close to your eyes and you look down at the granularity of the printer paper, you would see that the printer paper has a little bit of like texture to it, right? And that texture is kind of like the little dots, okay, on the paper. I generally think of pixels as the same thing, right? The white sheet of paper is a two-dimensional surface, and then the white pixel is a two-dimensional surface, and then you are basically, each one of those dots is a pixel on that surface, okay? However, when we're dealing with fog, fog inherently um, sort of it deals with three-dimensional space, right? So the fact that you have this fog here and it's moving and it has a certain level of granularity, it has a certain level of banding, as you can see. Um, in order for the application to really get the true essence of fog and not have it be, like we're not just painting, a shade of white on this picture, right? We're not just taking the color of the building and then saying, okay, let's put some white over it so that it looks like there's fog there, right? That would be sort of very superficial. It would almost look tacky, and it would almost look, it just wouldn't be a true representation of what's going on here. But especially like here, you could see that there's sort of a 3D texture to the fog, right? You could see that like this light beam is moving through the fog, and there is sort of a dimensionality to the fog, right? So in order for you to do that, in order for the application to do that, in order for the mathematics to work, we sort of expand the conversation from simply, you would even say a dot, or more specifically, like, a square or a rectangle, um, you know, into what we'd call a cube. So we basically take a cube of space in the scene. Okay, we take a cube of space. Um, think of a pixel, like, let's say you have a birthday cake, right, or a cheesecake, right, with no toppings or anything. Maybe it has icing on the top, but nothing else, right? You could think of the pixel as just the actual, just the very surface of the cake, maybe where the icing is or whatever, as the very surface of the cake. But if you were to basically, like, try to grab a cube out of the middle of the cake, so you basically have, like, a rectangle or a cube shape, object, like cylinder, but it's cubed, and you basically pressed it down into the cake, you know now you have sort of, and you press it down, and you grab out, you pull out, like, a cube shape out of the cake, going from the top to the bottom. Now you have, what you would call sort of like a voxel, right? So it's not just a two-dimensional thing. It's not just x and y. It's x and y and z. Okay, so we have this three-dimensional space, and the reason we have this three-dimensional space is because inside of that three-dimensional space, we're gonna have to deal with, like, things like light density, scattering, um, attenuation, um, sort of the propagation of the light rays, the noise, all that stuff, right? So you can't compress all these concepts into, simply a two-dimensional thing, like a sheet of paper. You have to sort of take the context of it in three dimensions, right? So x, y, and of course z, which z would be depth. Okay, so that's what I want to tackle today. But I also want to, just to keep it light and easy, and then also to get our hands a little dirty in terms of what's going on with this application. So what we're going to do is we're going to tinker with now, the settings for the scattering volume. Okay, so we have size of scattering volume tiles in pixels. Okay, so basically this scattering tile size dictates, basically how much granularity are we dealing with in terms of the fog, in terms of the volume scattering. Okay, so the larger the volume, the larger this setting. So we have it at 8 now, but the larger the setting is, the more, is a less granular or less detailed, the less resolution that we get, in our fog. So basically, the fog doesn't look as three-dimensional. It doesn't look as realistic. It doesn't look as cool as it did. So we had a setting of 8. The lower the volume, the lower the number is, the more, the higher the resolution and the more special the fog looks. The higher the number, the bigger sort of the tile is the less sort of granularity we have, and the less granularity we have, and the less the fog looks special. So we're going to run this now. We're going to run this with the number of 32 instead of 8. And when we run it, we're going to see now that the fog doesn't really look, it doesn't look like fog anymore. It almost looks like mist. And the mist looks very even, right? It looks very even. It doesn't even look like something is moving. It just looks like, it just looks like mist. It just looks like we took a paintbrush and we added a slight hint of a white mist or powder or something on the scene, right? So that's when we make the tiles bigger, right? I guess we could do 48 too. I believe 48 works fine too. So if we do 48, we should see yeah. So we get an error when I do 48. Okay. So let's get back to 32. Let's just run. We'll run 32, and we'll look back at what the low resolution version of this thing is, right? So we get to this, and we have sort of our very misty kind of thing. It doesn't even look like real fog, okay? So let's go back to 8, or actually let's do 16. Okay, I think 16 should run, right? So let's go to 16, and we should see, a progressively better sort of granularity, sort of 3D resolution. So you could kind of see where there's like an improvement. Like we could definitely see that the beams now, there's a difference between the beams and where there's not beams, and we could kind of see that there's something moving, you know. We can't really see it too much here, a little bit, but not too much, right? But then once we get back to 8, we'll see that we get even more resolution, right? So this is dealing with the tile size. Now, it says tile size, so I'm assuming this more deals with the two-dimensional side of the equation. But we could see now that we're getting more granularity in terms of the fog. The fog is looking more realistic, right? We're not going to get into too much math, but these numbers basically are multiplied together, and it gives you the general, basically the amount of information that we're dealing with, all that stuff. So let's collapse this now. I believe I could do 4. I might crash on this one, but we'll see. Yeah, okay, so we can do 4, and we could see that there's progressively better sort of, the fog has more, 3D texture, more vibe to it, right? If we go down to 2, which is the lowest I could go from previous experience, if I do 1, it's going to crash. But if I go down to 2, we're going to get maximum, sort of, granularity. Like we kind of really see now where things are really, you could see like the fog is tight, right? Like there's immediate definition in the fog, all that stuff. Maybe even a little bit too tight, because you could see like the light beams is a little bit too sharp, right? So maybe that's why in the application it didn't it didn't use 2 as the number. Okay, so we're not trying to get too deep into this stuff, right? We just want to sort of figure out what's going on with this thing in terms of volume scattering. Now, one thing I do want to note is that notice that the latency here, right? So we're at 200 to 223 when we use 2, okay? Now, if we go back up to, let's say, 32, if we go back up to 32, we'll see that generally speaking, we'll see that the latency falls, right? So you see the latency falls a lot, right? And this makes sense because there's less processing that needs to be done. The tiles that we're using, it's less of them because the tiles are bigger. So it's less processing that the renderer, the GPU, everything has to work through. The downside to that is that the fog doesn't look as realistic, right? In my opinion, or it doesn't look as granular. Now, maybe this is what you want. Maybe for your particular scene, for your particular application, maybe you look at this and you say this is ideal, right? I mean, what have you. But you could definitely see that the processing is not as heavy when we use a value of 32. Now, when we go back to the default of 8, we will see that we get somewhere in the middle. So we get a number that is, it's not 200, it's 85 to 108, right? For whatever it's worth, right? So and we do have a certain effect and all that stuff, right? So that is the scattering tile size. Now, remember we talked about the fact that the voxel has, it also has a depth component to it, right? So let us investigate the depth component. So we could do 32, and let us see what happens when we do 32. So instead of 64, we do 32. Okay, so we kind of see that, there's another twist to this thing. So this is dealing with, how deep do we go, the depth slices, right? We don't want to get too much deep into it, but we could see that, the fog looks a little bit uneasy here. It doesn't look as it doesn't look as realistic, honestly. But this is again dealing with number of depth slices in scattering volume, right? So if we do 16, we see that we get even more of this sort of, I don't even know how to describe it, but maybe this is what you want in your application. Maybe you want to have this sort of vibe, right? Maybe you're creating some kind of horror scene or whatever, and this is what you want, right? But the default, so can I increase this? I forgot if I can increase this. Let's do 64. I might, right, 64 was the default. Can I do, I'm not even sure if I could do this. I might get an error. All right, so that doesn't, so we have a depth component in this. And yeah, we can't really, when we go in the other direction, we can't really see much. Okay, and then we have the scattering range. Now this has to do with how far into the scene, how far into the scene from the camera do we process this stuff, right? So if I lower the value, we should see that the fog doesn't go as far in. That was my understanding, and we see that the fog doesn't go as far in, right? So maybe I think we're just seeing what's like close to the camera, but we're not. You notice that it's not really reaching to where the spotlights are, right? So we do still have light, and we do still see the light on the ground and all that stuff, but notice that the fog isn't there, and that's because the fog isn't being processed far away from the camera, right? So the camera the camera sort of rules the conversation, but we could see that it's not really going all the way into the it's not really going all the way into the scene. Now if we do 200, what we want to do is also look at, what is the latency. So let's see if the latency affects anything. So let us end it here. Okay, so when we go further into the scene, latency doesn't not really affect it too much. When we go further into the scene, we could see that we do get, we basically get what we had before, right? So maybe I shouldn't do that. I should maybe just do 50, right? So if I do 50, we probably should see more accumulated fog because now we're diving deeper into the scene. But then what's going to happen? Okay, so we dive deep enough into the scene where we do actually hit the spotlight. But what I want to do is give it a number where we're not actually, hitting the spotlights, right? So we tried 50, we still hit the spotlights. Let's do 30 and see if we get all right, so 30 we still get it, right? So if I do 15, okay, so 15 we still get it, but notice that the amount of fog that we're seeing, it's a lot less, okay? So let's just keep going. Let's do 8. All right? So let's do 8. All right, so 8 is too much because now we're not seeing, we're not seeing the spotlight. Let's do 9. No, let's do 11. So we're doing 11 now because we want to see if all right, we're getting some accumulation here. So the fog processing is going deeper and deeper into the scene, and as we get closer and closer, to the as we get closer and closer to the spotlight, we should see more definition, right? So this is dealing with the scattering range, okay? We see more and more sort of what have you, right? So if we do 14, we're gonna see that it hits the spotlight a little bit closer, right? So we're full on hitting the spotlight now. Let's do 13 then. All right. All right, so we're almost close to the spotlight, but we're not quite hitting it, okay? But you could see as we get deeper and deeper that this whole scene looks a lot more foggier because we're going closer and closer into, we're processing more and more fog going into the scene, right? So that if we go back down to 7 again, we'll see that this particular area, right, we see that this particular area is a lot clearer, right? Because now we're not, the fog all the way down here isn't as it's not processing too much fog when we look at the scene down here, right? So our default was 100, right? I do want to, let's go back to default, and then what I want to do is pay attention to that far away place. I want to see if it gets more cloudier as we do. So it's pretty cloudy already, right? Even at 100, even at the default, it's pretty cloudy. Like we could still see the light bulbs down here, but it is pretty cloudy, okay? Let's put this up to 300, okay? So we want to see now at 300, do we get more? We probably won't because, you know, even at 200, we're already seeing, yeah, it doesn't change anything. I need more distance. That's my problem. I need more distance. I need more distance. All right. Um, yeah, I'm not gonna get more distance. All right. So if we did 50 again, we should see that the far away scene is a little bit more clearer because we're not processing as much fog. No, it's pretty much the same. Let's do 25 or 20. All right, so we definitely see that it's clearer now, okay? But anyway, guys, my idea is not to get too deep into it right now. I just want to get us familiarized with these settings. Let me make sure I put everything back to default. I want to familiarize ourselves with these settings, and then number one, and then number two, I want us to understand what a voxel is, okay? Now, one last thing, but I will go into deeper detail in in another episode. Might not be the next episode, but I will go into deeper detail later. So we have what we call a voxel, okay? Now, for you guys that's been rocking with me for a while now, we are familiar with a concept called a frustum, a frustrum, okay? A frustrum is basically, all it deals with is it only cares about what is visible to the camera at the current moment, right? So right now we're looking at the frustrum for this scene, right? So everything that the frustrum is seeing, everything in the frustrum is basically being processed by the GPU, right? That's what the application cares about. It only cares about the things that the camera can see, right? So everything outside of the camera is not being processed by the application for obvious reasons. We're not going to heat up our laptop. We're not going to run down our battery. We're not going to be doing calculations for things that we can't see, right? So obviously when I move the camera, the frustrum changes and we do different processing because now we're doing for this scene and not what was over this side previously, right? So in this particular instance, when we're talking about volume scattering, there is a voxel, which we spoke about in this episode earlier, and then there's a froxel. Okay, so a froxel is basically we're only dealing with the spaces, right? The cubes. We're only dealing with the cubes that is visible to the camera. Okay, so it's an optimization of the voxel, and it is an optimization of general computer graphics where we're only processing froxels, or we're only processing voxels, however you want to slice it, but we're only processing froxels. We're only processing froxels, right? Which means that we're only processing voxels that are visible to the camera. Okay? Again, we're not interested in processing stuff that the camera can't see, aka you, the user, can't see, aka the monitor can't see, right? We have no interest in that stuff. We only care about what can be seen in the frustrum, what can be seen by the camera. So they combine voxel with frustrum, or they combine frustrum with voxel, and we call it a froxel, okay? That's an optimization that I will get to at a later date. but it is a thing that we sort of have to appreciate and understand, and that is what this application does. It basically makes it so that we're only processing voxels that are inside of the frustrum. Now, again, if you've been rocking with me for a while now in the Vulkan side of the equation, when we're dealing with Vulkan, I do have a series of videos talking about frustrum. It's specifically the the level of detail examples, where I basically I manipulate objects based on the frustrum, right? And I freeze the frustrum. So basically, I say, okay, I'm going to unfreeze the frustrum, and all the objects are shown in the frustrum, and all the objects that are outside of the frustrum are shown. Then I say, okay, freeze the frustrum. I click the freeze the frustrum button, and then only the objects inside of the current window that I'm looking at displays or are drawn, right? And then everything outside of what is being displayed, the window that is currently being displayed, all those objects are deleted or sort of not drawn, right? And when I pan after I freeze the frustrum, so I have a frustrum, I have a particular window that I'm looking out of for all the objects. I freeze it. Only those objects in the window are being shown. So then when I still have it frozen, when I have the frustrum frozen, and I pan the camera around where I had initially frozen the frustrum, you'll see that I could pan the camera and see that all of the objects have disappeared, right? But when I look at the area where I initially had my window, where I initially had the camera, all the objects are there, and you could see sort of the contour of the window. Like, you basically see kind of like a rectangle of objects, because that's the dimensions of the YouTube window, of the monitor, of whatever you're seeing. And then, like, when I pan it away from that area, you don't see any objects, because the indirect rendering is not did not draw those objects outside of the initial frustrum that I had. Okay, so I think that's enough for today, guys. We do have we do have a little bit of an intro into volumetric scattering. There's an X and Y component and also a Z component that makes a cube of the voxel. So we're not dealing with pixels anymore. We're dealing with cubes of space, depth, X and Y, but also depth, okay? And then we process based on that cube, okay? Because we're dealing with a three-dimensional concept, not just, we're not just painting some white over our scene and then calling it a day. We're actually doing doing some stuff with it. Some real three-dimensional stuff. Okay, so I'll leave it at that for today. Thank you guys for watching. Like, subscribe. You guys know this application is freely available online. In order for you to run this, you have to make sure that your system can run Apple Metal 4. Okay, so it has to be able to run Apple Metal 4. Which you could look up what the specifications are, but it's the latest iteration of Metal. There's Apple Metal and then Apple Metal 4. So this is the advanced rendering example, and I just decided, after doing the Hello Triangle example, which was just the initial introduction to Metal, I decided to go to the opposite end of the spectrum and go to the most advanced rendering example and just dive into it, right? Anyway, guys, thank you for watching. I now have an error, which I have to figure out why. I guess it was running too long. I don't know. But yeah, this is Code Education. Like, subscribe, share, tell your friends about it. Learn Apple Metal in 2026. Have a great day.